All right, guys, since we didn't have a lot of time to talk about how to work these problems, these energy problems, I'd like to help you walk you through doing the first one or two problems using this video lecture format. So please follow along with me as I go ahead and do this. First step to answering any of these problems, number one, read the problem. Number two, let's write down what we know. So let's read the problem together. How much energy in kilojoules does a 75-watt light bulb use when it is turned on for 25 minutes? Let's write down what we know. I'm going to pause. First of all, I apologize for sloppy writing. That's not my fault. It's the app's. Let's review what we know. We know that power is 75 watts. Time is 25 minutes. That energy is what we're looking for, but it should be looking for in units of kilojoules. We also know that energy is related to power and time because energy is related to power times time. And we also finally know that 1 watt is equal to 1 joule per second. So our next step will be to convert power units. I've written that here. What I mean by that is let's convert our power from a unit of watts to power in a unit of joules per second. And we have those conversions. Let's take a look here. You'll see that our watts is equal to a joule per second, and we know that we have 75 watts. You could probably do this in your head, but let's make sure that we're clear on how and why we're doing what we're doing. So I'm going to write it down in a second. So bear with me here. We know that we have 75 watts, and our trusty conversion table will help us solve this problem because we know that 1 watt is equal to 1 joule per second. I'm going to actually use my eraser to get rid of the rest of the line. And clearly, it's easy to see that we have 75 joules per second is equal to 75 watts. But a better way of writing it, and one that will allow us to continue to use our conversion tables, is to say that we have 75 joules for every 1 second of time. Okay, so that's power. Power, we know, is energy, joules, divided by time, seconds. Okay, but our answer can't be in joules and it can't be in seconds. We're actually not looking for either of those. We're actually looking for, I'm going to use, well, I don't have a different color. Here's my color. We're looking for kilojoules, and we're not looking at a time of seconds. We're actually given a time of minutes. So we have to work with those, and we have to do some conversions there. And I think if we use our conversion table, those conversions become a little bit more systematic. So let's take a look at our second step of dimensional analysis. So here's our next step of dimensional analysis. We know what we're given. We're given 75 joules over 1 second. That's what we start with. And we use our conversion table to make some conversions. The first conversion we don't want seconds in our final answer. We're given minutes. So we want to convert from seconds to minutes. Okay. And our second conversion, we don't want to use joules. We'd rather prefer kilojoules. So we want to convert from joules to kilojoules. Once we do that, we'll be in a good position to actually look at and answer our question. So let's try to do so. Converting from seconds to minutes, we know that 60 seconds is equal to a minute. That's easy. I put seconds up here because I know that my seconds is in the denominator, and I want to be canceling out those units. Fantastic. Okay, and I know I want to convert from joules to kilojoules. My joules starts out in my numerator, so I'm going to put 1,000 joules is equal to 1 kilojoule because kilo means 1,000 times bigger. So there's 1,000 joules in a kilojoule. Fantastic. Let's solve our problem then. Okay, so let's solve this. We can cancel our joules in our both in our numerator and in our denominator. So what we're left with here is 75 times 60 divided by 1,000. That says 75 times 60 times 1 is divided by 1 times 1 times 1,000. Okay, what I end up with when I plug that in my calculator is, not 7.5, is 4.5. Okay, let me write that again. 4.5. Now what are my units? I'm going to squeeze them in here. I know kilojoules per minute. Oops, there we go. That's sort of tricky to read. We have 4.5 kilojoules per minute. That's the power that we're working with. Okay, that's the amount of power converted from joules to kilojoules and from seconds to minutes. This doesn't answer our question, however, because our question asks how much energy. We now know that our power is equal to 4.5 kilojoules per minute. And I know I still haven't actually used my time of 25 minutes. I already told you that power is equal to, that energy is equal to power times time. So let's do that. Power times time. Energy is equal to 4.5 kilojoules per minute times the 25 minutes. Oops. Of course, that looks sort of like our conversion table, and our minutes are going to be canceling here. So what's 4.5 times 25? Final answer will be 112.5 kilojoules. My final answer. Okay, that helps me walk through that first problem. I'm going to stop the video here. I'd maybe encourage you to re-watch it. Let's analyze what we did here. I'm going to use it in different colors. Our first step, list what we know. Second step, we converted our power units to things that we can work with. That is to say, joules and seconds. All right, our joules and seconds are something that we can work with. Our third step was dimensional analysis, where we converted from seconds to minutes, from joules to kilojoules. We converted to these units because they're the units we were given, and they're the units that we were looking for. And finally, we used our equation that we needed, our energy equation, to plug our final answer in and get 112.5 kilojoules. Hopefully that helps you solve question number 1 and understand it. We'll do question number 2 in a second.